Everybody. My name is Josh, and I'm from Mission Control on the eCYBERMISSION team. I would like to thank you so much for your interest in the 2011-2012 competition, and we can't wait for another great year. The purpose of today's webinar will be to discuss testing your hypothesis through experimentation. In today's session, Cyber Guide Bird will be joining us, and he will cover the necessary elements to test your hypothesis. And this will include the steps in preparing and conducting an experiment, the key elements of an experimental procedure, independent and dependent variables, and the differences between experimental and control groups. But first, let's review the rules of engagement for today's webinar, and then I'll introduce you to Cyber Guide Bird. And after that, I'll turn the presentation over to him so that he can help you get ready to test your hypothesis through experiments. On a serious note, the safety of our students is always our top priority. During the webinar, please remember not to use your name or location. And as a reminder, you should follow this rule when using the discussion forums and the team talk on the website as well. Your safety is always our top priority. I also have a couple pointers for you regarding using the technology. You should all see a control panel for the webinar on the top right of your screen. And there's a section called Questions, which is where you can type your questions throughout the session. On the left of the control panel, you should see a symbol for a hand. At the end of the session, if you want to ask Cyber Guide Bird a question over the phone, just click that digital hand and it'll raise it, and I'll unmute your line so that you may talk directly to him. In this environment, it is very important that we all remember to treat each other with respect and each question with respect. Please provide the presenter with your full attention and make your fellow students feel comfortable when they ask questions. Remember, the only bad questions are the ones that go unasked. Okay, let's move on. Now I'd like to introduce you to Cyber Guide Bird. This is his second year volunteering with eCYBERMISSION, and Cyber Guide Bird is a major in the U.S. Army. And he teaches chemistry at the United States Military Academy, or West Point. He has also served overseas in Afghanistan and Korea, and we're thrilled to have Cyber Guide Bird here with us today. Cyber Guide Bird, I'd like to start off with asking you, what first got you interested in science, technology, engineering, and math, or STEM?
Well, as I teach here at the academy, I realize that the need to be able to interest the the middle school and high school age students into the possibility of studying something in STEM, and so this is a proper opportunity for us to have a STEM outreach program, and so that's how I kind of got interested in teaching STEM and then trying to outreach to schools through eCYBERMISSION.
Okay, that's wonderful. Well, I'm excited now to turn the presentation over to you. So take it away, Cyber Guide Bird.
All right, thanks everyone. So that's great. You guys are off to a great start. Here are the questions that you will answer in your mission folder under the experimental design phase, or if you're working on an engineering design process mission folder, the build prototype phase. For the rest of the session, we are going to give you tips on how to write your experimental procedure and conduct your experiment. So after you have presented your hypothesis and prediction in the previous phase, you're now ready to begin writing your experimental procedure to test whether your hypothesis is true or false. The experimental procedure is a step-by-step recipe or technique for the science experiment. A good procedure contains enough details that it lets someone else be able to redo or duplicate your experiment. So let's talk about some of the key elements of experimental procedure. Your experimental procedure should include a detailed description and size of all the experimental and control groups. You should also be sure to include a step-by-step list of everything that must be done in order to perform the experiment. Think of all the steps that you will need to complete the experiment. Be sure that you record down in a journal somewhere what will need to be done in each step in your scientific notebook. Another way to think about this is to compare it to writing a recipe for your experiment. After you identify your independent and dependent variables, your experimental procedure must explain how you will change the independent variable and how you will measure the resulting change in the dependent variable or variables. If applicable, Your experimental procedure should explain how the controlled variables will be maintained at a constant value. And then repeat or do it over and do it over and do it over. And you should specify in your procedure how many times you intend to repeat the experiment. Repeating each experiment you conduct several times will help you verify the results and show that they are reproducible. You should plan to repeat each experiment at a minimum of 3 times. Finally, a good experimental procedure enables someone else to be able to duplicate your results and do it exactly. So use the experimental procedure as a tool for others and make sure you're as detailed as possible. The first step of designing your experimental procedure involves planning. How are you going to change your independent variable and how the measure will impact the change on your dependent variable? To make sure you have an accurate test when you're conducting your experiment, you need to make sure that the only things you change are the independent variable. All of the controlled variables must remain constant. Only then can you be sure that the change that you're making to the independent variable actually caused the changes you observe in the dependent variables. To design your experiment, begin by asking yourself, what can I do that will give me one result if my hypothesis is true, and a different result if my hypothesis is false? So make a list of the things that would be true if your hypothesis were true. Use the predictions you made in step 2 of your experimental procedure and design an experiment to test each of those hypotheses. All good experiments need to be 3 things. The first is that they need to be controlled. Good experiments are conducted in a controlled environment, meaning a place where outside factors can't interfere. This is why so many experiments are done in labs. For an experiment to be valid, it must be repeatable or repeated several times so that you have enough data to compare it. Comparisons between your control group and experimental group will allow you to see patterns or relationships in the data. This will help you be sure the results of your experiment are accurate. Make sure you repeat your experiments to collect all the data you need to make these comparisons. And good experiments are objective, and that they are planned to avoid bias. Scientists work hard to be sure that they don't let their personal opinions affect how they plan or conduct experiments. Good experiments collect quantitative or numerical data or results. You check to make sure the experiments you planned will produce numerical data, not something you feel is right. Each time that you perform your experiment, it is called a run or a trial. You will most likely want to include how many trials you intend to run in your experimental design. In some experiments, you can run the trials all at once. For example, if you're growing plants, you can put 3 identical plants or seeds in 3 separate pots, and that would count as 3 trials. Every good experiment compares different groups of trials with each other. Comparing the groups helps ensure that the changes you see when you change the independent variable are in fact caused by the independent variable. There are 2 types of trial groups, experimental groups and control groups. The experimental group consists of the trials where you change the independent variable. For example, if your question asks whether fertilizer makes a plant grow bigger, then the experiment group consists of all trials in which the plants receive fertilizer. In many experiments, it is important to perform a trial with the independent variable at a special setting for comparison with the other trials. This trial is referred to as a control group. The control group consists of all those trials where you leave the independent variable in its natural state. In our example, it would be important to run some trials in which the plants get no fertilizer at all. These trials with no fertilizer provide a basis or a baseline for comparison. It would ensure that any changes you see when you add fertilizer are in fact caused by the fertilizer and not some other outside factor. However, not every experiment is like our fertilizer example. In another experiment, many groups of trials are performed at different values of the independent variable. So let's go over a quick example. If your hypothesis asks whether an electric motor turns faster if you increase the voltage, you might do an experimental group of 3 trials at 1.5 volts and then another 3 trials at 2 volts, and then another 3 trials at 2.5 volts, and so forth and so on. In this type of experiment, you are comparing the experimental groups to each other rather than comparing them to a single control group. You must evaluate whether your experiment is more like the fertilizer example, which requires a special control group, or more like the motor example that does not. Because obviously, if you're running a motor and you have no power, then it wouldn't turn at all. So whether or not your experiment has a control group, remember that every experiment has a number of controlled variables. Controlled variables are those variables that we don't want to change while we conduct our experiment, and they must be the same in every trial and every group of trials.
Okay, let's go ahead and move to slide 12 here.
Prior to conducting the experiment, make sure you and your team review your experimental procedure. Are all the necessary steps written down? Do you have any questions about how to do any of the steps? In fact, it's a good idea to do a quick preliminary run of your experiment. Show your preliminary data to your team advisor when you review your experimental procedure. There's often glitches in the procedure that are not obvious until you actually perform the experiment. That is to be expected. Make sure you think about safety. Are there any safety precautions you should take? Do you need an adult to supervise? Do you need to wear gloves or goggles? Do you need to keep a fire extinguisher nearby? Follow the experimental procedure exactly. If you need to make changes in the procedure, which often happens, you need to write down the changes exactly as you make them. And if possible, take pictures of your experiments along the way. These will help you explain what you did to the virtual judges and enhance your mission folders. Videos and model drawings also help to emphasize your mission folder. It's very important to take very detailed notes as you conduct your experiments. In addition to your data, record your observations as you perform the experiment. Write down any problems that occur, anything you do that is different than planned, ideas that come to mind, or interesting occurrences. Be on the lookout for the unexpected. Your observations will be useful when you analyze your data and draw conclusions. Remember to use numerical measurements as much as possible. If your experiment also has qualitative data, or stuff that's not numbers, then take a photo or draw a picture of what happens. Now let's go over an example of a checklist for your science experiment. A good science experiment, you should answer yes to every of the questions you see on the screen here. Why doesn't everybody take a look at the checklist and submit any questions you may have through the question section on your control panel?
Okay, looks like there are no questions.
Okay, everyone. Now you are ready to test your hypothesis. So go out and conduct your experiments. And so at this time, I'm going to turn this presentation back over to Mission Control.
Okay, great. Thank you very much, CyberGuide Bird. We'd like to thank you very much for taking the time out to talk to everybody today. As a reminder, everybody, you can contact Mission Control via our telephone number or our email address at any time if you have any questions at all. And good luck on your projects.